Yeah, Grant Ingersoll again, author of Taming Text and Mahout co-founder and Lucene solar guy. Gave the solar talk this morning, and now I'm doing the Mahout talk. So happy to be here and happy to talk about my baby, I guess, as it were, and tell you about the ways it's grown up and where we're hopefully headed as well. So how many people here are using Mahout? One, awesome. So I'll give a little bit of a background here. So what is Mahout? You guys have probably used Amazon before. When you're on Amazon, you're looking at a specific thing, they often show you something like this. Customers who bought this item also bought that item. This is known as collaborative filtering recommendations. This is probably the thing that Mahout is most known for, has built into it a number of different approaches, libraries, et cetera, for doing collaborative filtering based recommendations at scale. Primarily Hadoop based, but it also has single node implementations as well. I think, if you look at the Netflix prize, we implement the majority of the techniques that were used to win the Netflix prize, for instance. So lots of people using it. In fact, Amazon, as part of their IMDb movie recommendations product, not their core recommendations, uses Mahout recommenders as well. Okay, so a lot of good use cases out there for that. What is Mahout in another sense? Throw up some dots there, throw up some shopping cart. Mahout does clustering, right? It can take a bunch of unseen items and it'll try to make sense of how to organize those things together. So put all the yellow things together, put all the red things together, put all the blue things together, basically based off of some notion of similarity, right? So you just throw all this data into what's called a feature vector, you say, go cluster this. And we've got a bunch of different ways you can try clustering. This can be useful for, well, one, you can build recommenders for this out of clustering approaches. Two, you can also do things like basket analysis if you're looking at shopping carts, et cetera. A lot of people also use clustering, for instance, when you've got a whole bunch of news items coming in. Cluster all those news items so that you don't have to read the same stupid article about Miley Cyrus over and over and over again, right? Because you saw it once and that's all you need to see it. Mahout is not Arnold in Terminator. This is not, artificial intelligence, all of that thing. So I just wanted to throw that up there. Sometimes people hear the word machine learning and they think, oh my God, the machines are going to take over. Skynet has become self-aware. Mahout is at least not that, and I don't know of any machine learning at this point who is. So. But it is, however, probably the third C. If you've recognized the trends, I said collaborative filtering, and then I said clustering, and the third one is classification or tagging. Mahout provides classification capabilities. If you were just in the predictive modeling talk, that's also another way of saying classification. Mahout provides a number of different ways of doing classification. So in this particular example, what we're trying to do is apply tags to articles in Stack Overflow. Can we automatically classify this content into specific buckets? Right, what are the labels? So again, that can help you. If you're only interested in technology articles, I can, if the system tells me right away that this is about politics or this is about entertainment, then I don't even need to bother with those news articles, whereas I can then focus in on the technology specific ones. Okay, so that's the third C, if you will. On the other side, it's not Hal. We don't like him anymore. If you were into Space Odyssey 2001. It is, however, the Matrix. I throw that up there. It's kind of tongue-in-cheek in some ways. I don't literally mean it's that kind of matrix. What Mahout does underneath the hood, in order to build those three Cs, well, you need a whole bunch of libraries like matrix libraries and primitive collections and all of that kind of stuff. And it turns out that if you're going to do this at scale, it's really handy to have those kinds of libraries around that are really, really fast. And so even if you don't use Mahout to do the three Cs, you may find that our matrix library and our vector representations and all of those things are useful for you nonetheless, right? We also have primitive Java collections, i.e. ints and floats with lowercase as opposed to integers and floats with in the object sense in the capital I and capital F. If you don't think that matters, try doing this stuff at scale and wait for your garbage collection in Java to basically put your algorithms to a standstill, and then you'll come back and say, I really could use that collection that you guys have over in Mahout. We have a whole bunch of statistical packages as well, so a lot of that stuff that you need to do this is all right there and packaged as independent jars. You don't have to get the core or any of the other libraries in order to do that. So what are some of the use cases, just to put that into words? Recommendations. Turns out there's a lot of different kinds of problems that you can see as recommendations, whether that's content or whether that's users clicking on things, whether it's dating sites, whether it's trying to match up stocks, whatever. Classification of content, finding similar content, we also do that. We can find things like, with Mahout's packages, things like statistically interesting phrases. So these are pairs of words or multiple words that co-occur together. More often than one would leave to chance or leave to a normal distribution. That can be really handy when you're trying to show users what are the important things in a large collection of content. Some ways you can think about it as word level clustering, although I wouldn't technically call it that. And so there's just a lot of different techniques in Mahout to do these kinds of things. So in a sense, what we're trying to accomplish in Mahout is to be a set of machine learning libraries for solving common machine learning problems. We're not always going to be the latest and greatest algorithms. We're going to try to focus on a couple of different things. Ones that algorithms that have been proven to work, and algorithms that we think we can make scalable. So this is kind of a fancy definition around machine learning, but you can go and learn more about it. At the end of the day, if you want to really be into machine learning, I think there's a lot of different fields that are useful here, and that's one of the things that keeps me interested is because you get to apply a lot of different parts of your background, your math, your computer science, all of that kind of stuff. What is Mahout then? It's an Apache project. I call it Mahout. A lot of people call it Mahout. The running joke is that if you have it in production, you can call it whatever you want. So at the end of the day, Apache licensed, open source machine learning focused on scalability. That doesn't always mean Hadoop, but in many cases it is Hadoop. So for instance, if you were in Claudia's talk earlier, she was talking about stochastic gradient descent, logistic regression. We have an implementation of that that's pretty fast, maybe not as fast as what she needs, which is why I think she probably rejected it, but it's pretty fast for most cases. And it doesn't use Hadoop at all. It runs all on one machine, and then you, of course, can replicate the models if you want. But it turns out a lot of that covers a whole lot of the cases you have for that kind of classification anyways. Really started Mahout in many ways because at the time, this was back in 2008, there really wasn't any good open source Apache licensed machine learning libraries available. Now that has really since changed. There's a lot of good ones out there, and they focus on different things, but we felt at the time that we could solve a number of these issues like lack of community documentation, etc. The requisite logo slide. There's a bunch more up here. I know all of the major Hadoop vendors all package Mahout in with their distributions as well. So you pretty much can get Mahout pretty easily these days and use it as you see fit. So that's all well and good. That's kind of the background on Mahout. So where are we now, right? Well, we're in that little part of the universe, and maybe someday we'll be on the other side. So what I wanted to cover kind of in going forward here is what do we have and where are we going? Any questions so far on what Mahout can do or what its use cases are or anything like that?
Did it organize that cluster?
Maybe it did. I don't think Mahout did. Yep.
Yeah, so I've got a bunch of these unnormalized location strings, places of organizations where people didn't know how to spell their organization, they didn't know their zip code, they didn't know how to spell Albuquerque.
Yep.
And so would Mahout be able to cluster those into the true organization?
To the true, so like, were you in the earlier talk where she was talking about Dun and Bradstreet problems next door? So this problem of record linkage essentially, is this Bob really that Bob kind of problem is essentially what it is. Yeah, so I mean, Mahout can, I don't know if clustering could be, you could see this as a clustering problem, you could see this as a classification problem. If you were at my earlier talk, you can also see this as a search problem. can also be seen simply as a fuzzy string matching problem. I think when I do record linkage problems like that, I typically look at it as it's a multifaceted one. So machine learning will probably help you with some percentage of those cases. You're also going to need, just tried and true heuristic approaches like you would use with fuzzy string matching, with search, etc. And then ultimately what you're getting at is you'll get some percentage that are really easy, either positive or negative, and then that gray area you need to surface up to people to make an ultimate decision on. And even then, you'll still have failures. So can it solve the problem? No. Can it help with the problem? Yes. Hopefully that helps. I think it would make your life easier, at least as that first pass or second pass on the data, but ultimately you're still going to have that gray area where you need to get involved and have somebody look at those edge cases, right?
Yeah, it's better current method. Better over the self-written cluster that takes care of the gray area.
Yeah, I mean, you could basically, if you can represent all those different things as features, ultimately at the end of the day, what Mahout works off of is what we call feature vectors, which, at the end of the day is just a bunch of weighted values, right? And so you can say, this is my weight for this feature, and you can apply the clustering algorithm to it. It may, depending on garbage in, garbage out, you may not get good results, but you can at least try and then iterate and improve your model essentially and see if you get better results over time, right? So, that's kind of an important point, I think, when it comes to machine learning. This is not a panacea. This is not a silver bullet for all problems. It can help usually. It can help take the tedium out of a lot of these tasks, or it can at least help you address tasks that normally are intractable to humans, or, you've got to go do like mechanical Turk kinds of things on them, et cetera, which can be pretty expensive, right? So where are we right now with Mahout? We just released, I think last month, 0.8. It had a number of different themes, which I'll cover here. And then I'll talk a little bit about 0.9 and 1.0, which are kind of on the horizon for us right now. One of the key things that we really focused on and are focusing on as we get towards 1.0 is really kind of locking things down and what we think we're good at, what we want to support, and then making sure those things are, in this case, faster. So we've gone through and done a lot of updates to try to make sure that the underpinnings of this stuff is fast. And so things like our vector libraries, our matrix libraries, our stats, our math, all of that kind of stuff, just going through and reviewing where can we improve how we do these things, as well as the way we iterate over all of this content. Because again, when you're doing a lot of this stuff, you're often going over all of the data. You want to make sure that's very, very fast. And then we've made a number of performance enhancements for recommenders. So for instance, I believe one of the more popular recommenders is called alternating least squares. I think they've taken that, they've roughly shaved an order of magnitude of time off of that and reduced the number of iterations it takes to do this. One of the things we've also found along these lines is with Hadoop, this kind of batch or iterative, a lot of these machine learning algorithms are iterative in nature, which means you have to spin up and down several Hadoop jobs before you actually converge to an answer. So in Hadoop 1, that can be really expensive. So anytime you can remove iterations from the process or you can get to convergence faster, you're going to be a lot happier, right? And so that's where a lot of our performance focus has been. Now with Hadoop 2 and all of the yarn stuff and all that, you're starting to see more iterative support. You're starting to see programs or libraries like Spark, et cetera. Those are also proving to be well suited for these more iterative machine learning programs. So one of the things we as a community are looking at is should we be using those kinds of models as opposed to just using Hadoop. So faster, oh geez, PowerPoint, nice. Apologies. It's not good when you just hit the forward button. So let me see if I can get back to where I was quickly. One of the other things along with trying to make things faster is really taking a hard look at what algorithms we want to support. Are these the best algorithms out there as far as we know and are able to implement in the time periods that we're interested in? And so can we make upgrades here? One of the big new ones that we added is a new clustering algorithm called streaming k-means. If you're familiar with clustering, kind of the tried and true method of doing clustering, it's very easy to implement, is called k-means. Works reasonably well, but not great. It also has that iterative problem that I talked about, which is it can take many, many steps for the clusters to converge. We've actually implemented a new one called streaming k-means, which I'll talk about here in a little bit, that is a lot faster. It essentially can do more or less the equivalent of k-means in only one iteration, right? Some other ones, things like parallel SGD matrix factorizer. So this is using a stochastic gradient descent approach to matrix factorization and then also doing that in parallel, i.e. on Hadoop. We've got one of the underpinnings of a lot of machine learning algorithms is called singular value decomposition. We've upgraded some of the capabilities around that. Singular value decomposition essentially allows you to separate the noise from the signal, if you will. And then we've put in a whole bunch of new I/O options, better integration with Lucene. You can guess who did a lot of that work, because I like to take all my stuff that I've done in Lucene and then put that into Mahout so I can do these kinds of algorithms across my collection. Better support for more things like sequence files from directories, etc. So also, we've got I/O integrations with things like HBase and Cassandra and Mongo and all of that kind of stuff. So those are all available in Mahout too. A little bit more information on streaming k-means. There's the algorithm kind of written out in pseudocode. Essentially what it does is as it goes through, it can do this all in one pass, going through the data. It basically, in the old way of doing k-means, you would randomly select k points out of your cluster or out of your potential, or out of your space, and you would say, oh, well, let's pretend this one's a centroid, i.e. the middle part of a cluster, and this one over here is a middle part of a cluster, middle part, etc. And then it would iterate every pass. It would go through and try to refigure out which, or recalculate which ones, where should that centroid of that cluster be, right? With the new approach, basically what we do is we go through, and when we look at the very first point, we say, oh, well, that's a centroid. And then we see another point over here, and we say, oh, that's a centroid. Okay, so far so good, right? We've got a centroid over here and a centroid over here, right? So then the question becomes, what happens when I have another one over here, right? Should that be in the cluster or not? And so you can do this calculation with the distance cut off, et cetera, say, should that be in the cluster or not? If not, then make it a centroid. If so, then just add it. And so you can just iterate and do this all in one pass. And there you're done. So if you want more details on that, I won't pretend to be the expert on here. The guy Dan Filliman, who's a Mahout committer, gave a talk on that at Berlin Buzzwords, which covers all of the gory details, shows you how to do this in MapReduce, et cetera, et cetera. Okay? Whew. It's the holiday season. Everybody wants to slim down. We're doing that in Mahout as well. Back in the early days, we kind of were, let's take on all comers. We didn't really know what would stick, right? So we had implementations of all kinds of algorithms. We had genetic algorithms. We had a bunch of different clustering algorithms that nobody ever used. We had, let me try to think what else we had in there. Some like implementations of graph algorithms like PageRank, et cetera, et cetera. And kind of over the years, we've really realized that, that's not our core area. We don't have enough committers who are experts in all of those areas, or the community itself hasn't expressed much interest in those things. And so let's just get rid of them. Sure, they're fine. They're fine algorithms, but we don't have the bandwidth to do that. Or like in the case of like the graph algorithms, they're better served using a real graph database like a Neo4j or a Giraffe or one of those kinds of things. And so, go do PageRank in a graph algorithm. You'll be much happier than you would in a Hadoop iterative approach, right? And so there was no point in maintaining those things in Mahout. What does that mean for you as users, or the one person in the room that actually is a user right now? You may have to go through and look at your deprecation list and the readmes and all of that kind of stuff and see if you need to go and clean some things up there. Okay? All right, so that's 0.8 as of now. Any questions on that? So where are we going? Like I said, we're trying to lock things down, more code cleanup, et cetera. A lot of focus still on performance testing, et cetera. One of the other things I think you'll find about Mahout, and this is perhaps true of Hadoop in general, or at least when you first get started with Hadoop, is you tend to do a lot of things of command line oriented. It's go submit this Hadoop job, have it go do a bunch of things, and then when it's done, come back. We're trying to make it better, more consumable as part of a program, so better APIs, perhaps REST-based services that allow you to interact with Mahout much like you would interact with a Solar or with an HBase or something like that, where you can submit your jobs, have them go off and do their thing, come back, and so you can programmatically integrate it as opposed to being more focused on the command lines, et cetera. The other thing that I haven't been involved with that much is some of the committers are actually adding Scala support for the math libraries. And so if you want to go in and you want to use Scala to do the mathy kinds of things that Mahout can do, that should be in 0.9 as well. So that's 0.9. And then looking ahead at 1.0, this is really where we're committing as a community to backwards compatibility, so that's really probably the biggest feature there. There are a few others though. So I mentioned we have that essentially single node or single machine SGD. We also have, I believe, in the works, and I don't know what the status of this patch is, but a Hadoop-based stochastic gradient descent, which traditionally has been pretty hard to implement in a MapReduce style mode, but I think somebody's figured that out and is working on an implementation there. At this point, kind of when you get towards that 1.0, we've locked down on those 3 C's. A lot of the work then becomes what kind of tooling should we be providing to users? If you're a Weka user, for instance, you're probably you're really used to a really nice set of UIs and those kinds of things for solving these kinds of problems. Mahout traditionally hasn't focused on UIs and that kind of interaction. I always joke with people, there's a reason why I work on the server side. I can't design a UI to save my life. So that tends to be the case with people in this in this space as well. So perhaps somebody who is better at those things will stand up and say, hey, here's a front end to this. Here's a front end that lets me explore this data and then pick the best algorithms to do what I need to do. Some of the committers have also looked at JBLAS, which is BLAS is a long-time linear algebra package. I believe it's written in Fortran. Somebody can correct me if I'm wrong there. So really, really fast, time-tested, proven in the scientific community for doing matrix manipulations, et cetera, for, I don't know, probably the past 10 or 20 years. So some people have tried using JBLAS with Mahout, and they're seeing some pretty significant performance improvements in terms of these matrix factorizations, which are often the underpinnings for a lot of these higher level algorithms that we're using. And so that stuff is in there, should be coming as well. And then last but not least, I think we're starting to see more interest as the companies like Cloudera and Intel and MapR, et cetera, that all these Hadoop distributions are broadening their reach. They're also then looking at how can I make this easier to use Mahout in terms of connecting to data sources and visualization tools, et cetera. Some in the community are looking at how you can use Mahout with R, for instance, et cetera, et cetera. So that's about it. I'm happy to keep it short. I know I'm the last talk of the day, so I kind of thought I would keep it a little bit short. Happy to answer questions on this stuff. If you want, it's a little bit out of date, but Mahout in Action still covers the high-level concepts of this. Some of the examples aren't necessarily up to date, but that's probably what I would consider as the Bible on Mahout. I cover clustering and tagging or classification and taming text. In fact, that Stack Overflow example is straight out of my book on that stuff. So if you want to look at examples there, you can do that as well. Otherwise, the website, the mailing lists are usually the best place to get answers. So with that, any questions? All right, cool. Yep.
We're looking for a topic modeling.
Topic modeling.
Something
Yep. So Mahout has LDA implementation and some variants off of that, which is kind of the more or less the standard for topic modeling. I don't know if anybody's donated yet kind of some of the newer variations off of LDA, the ones that actually can generate the labels as well. So Mahouts will generate the topics and kind of give you all of the indicators of the topic, but they won't necessarily say here's the label. Whereas things like, I believe it's called like LDA++ or some of these variants of LDA have since then gone and done those things. So there are definitely people in the community who are doing topic modeling with Mahout. So you probably best just ask there. I think that's one of the broader things with Mahout that you'll see as well. We'll often tell you don't use Mahout, go use this. So if you just ask, there's a bunch of machine learning experts that are participating in the community, and they'll just say, hey, here's where you should get started, here's what you should avoid, and go from there. So like a lot of times R or somebody else is going to be better. We try to focus in on specific kinds of problems at scale. And so, go do that as well, and just ask. Sure.
Do people use these things sort of in like business applications to try and give like user hints, for example, like you sort of we work in document management, so like people create these types of documents and trying to track that kind of thing, so you kind of pre-populate lists with things that are likely candidates for what they would do. Or
yeah, so the question was on, how do people use this stuff in business? I mean, I think that's, document management is a perfect example. I mean, you see classification used a lot in document management, i.e., trying to classify content into an organization's taxonomy. That's a pretty common classification process, especially if you're a technical organization, scientific organization, et cetera. I mean, recommendations, like if you're an e-commerce site and you don't have recommendations these days, chances are you're probably losing a good bit of opportunity with your customers. Clustering to me is always one of those things that it's kind of cool to think about, but I don't see as many people using it as often. But there still definitely are cases there. Clustering tends to be more exploratory. So it's like, hey, if you want to present something to the user, it often goes with search as well. So search is great when you kind of know what you're looking for, or more or less. Clustering can be a way of presenting the content to users such that they can go explore around in it without kind of losing track of where they are. And then like some of the lower level stuff, like I use the statistically interesting phrases. We do that. It's also like a discovery aid. Because what you kind of find, I think, these days, especially when it comes to document management in your space, right? You need really good search, because that's when a user knows, hey, I want that document that's titled this. But then discovery is really all about how do I show them things that they perhaps weren't aware of, or they didn't know how to express as a search need, right? So discovery can be things like clustering, classification, but it also can be more subtle things like just correcting their spelling and that kind of stuff, or giving them type ahead, and so these kinds of things can help with those as well. Cool. Any other questions? Yep.
In case of collaborative filtering for recommendations, while getting to the final result, this bunch of steps that it might produce, and in between, meanwhile it's doing back processing, does it store intermediate data somewhere before it produces the final result?
Right, so the question was, what's essentially the process, the high-level process around collaborative filtering?
And also the intermediate data, does it store anywhere, or is it like?
Yeah, so kind of, your typical collaborative filtering, right, is you've got your website, users are clicking all around that, that's generating all kinds of logs. That all typically then flows into Hadoop, right? You do some pre-processing of those logs. What Mahout cares about for collaborative filtering is usually either a triple, user, item, rating, or just user and item, and essentially it's a Boolean, right? So you'd only show up true. That's essentially you're expressing a positive preference. And that's all it takes in. So you can literally give Mahout like a CSV file if you want of those triples, or you can write them out as sequence files. And then it will go and do Depending on the algorithm will depend on what intermediate steps are done and what data is generated from that. But like in the a number of cases where you're essentially doing item-to-item recommendations, there's some splitting apart of the data into intermediate files that you're essentially calculating co-occurrences between items. Those intermediate matrices are then used to generate the final model, which is the one where you would say, oh, this user's on this item. What other items should I be showing those?
And is there a way to persist the co-occurrences as such in while it's processing?
I'm sorry, what was the?
To persist that co-occurrences.
To parse it?
Yeah, while it's processing, it basically calculates the co-occurrences and based on that it gives you the result. But if you want to go back and see what are the co-occurrences as such.
Right. So I mean, typically with really, the only time you would use this stuff is there really large-scale recommendations, right? And so typically those are done. Most stuff, as in most stuff in Hadoop, this is done batch offline, right? So you have access to all those intermediate files. I mean, you could go and parse them yourself, but ultimately at the end of the day, it's spitting out, per user, here's the model, right? And it should be noted there's other ways of doing this too. This only covers essentially voting-based recommendations. It doesn't cover content-based recommendations. And of course, because it's there's other issues with those recommenders too in terms of dealing with if you've never seen a user before, or if things are updating quickly, or if there's not a lot of information about a particular content at some point in time. That being said, what you quickly find is that you kind of reach a steady state for most items pretty quickly, right? Because once you've got 10 reviews or 50 reviews, having 51 reviews doesn't change the model all that much, and so you can kind of live with this calculate every hour kind of approach or every night kind of approach. So, any other questions? All right, cool. Thanks.